Welcome, another learning day for you. You are able to illustrate an arithmetic sequence and to find the common difference. In this lesson, we will determine the nth term of an arithmetic sequence. Let us have a review. Activity: what is missing? Direction: find the missing terms in each arithmetic sequence. Answer 30 and 39. We have -7 and -12. Answer 19 and 33. (11 and 38). (2 and 22). Were you able to find the missing terms? If so, let us proceed. Next activity: what do we have in common? Below are squares formed by matchsticks. Count the number of matchsticks in each figure. What did you notice? Is there a pattern in the number of matchsticks? What do they have in common? Take a look at the completed table below. Let us take the number of matchsticks: 4, 7, 10, 13, 16, 19, 22, 25, 28, and 31. We see that the number of matchsticks forms an arithmetic sequence. Suppose we want to find the 50th term of the sequence. How do we get them? We could find a formula for the nth term of the sequence. Let us use the previous example. Let us take the first 4 terms. Let a sub 1 equals 4, a sub 2 equals 7, a sub 3 equals 10, a sub 4 equals 13. How do we obtain the second, third, and 4 terms. Consider the table below and observe how each term is rewritten. Notice that the first term is not rewritten. 7 is expressed as 4 plus 3, 10, 4 plus 3 plus 3, and 13 as 4 plus 3 plus 3 plus 3. How else can we write the terms? We do not add anything to the first term, that's why we have 0 multiplied by 3, and it is the same as 4 plus 0 equals 4. In the second term, we add 1, 3, that's why we have 4 plus 1 times 3, and they are both equal to 7. In the third term, we added 2, number 3, that's why we have 2 multiplied by 3 and added it to 4, they are both equal to 10. In the fourth term, we added 3, number 3, that's why we have 3 multiplied by 3 plus 4, and that is the same as 13. When terms are rewritten, notice that each term of the arithmetic sequence has something in common. They have 4 and 3. Note that 4 is actually the first term of the sequence. Recalling the definition of arithmetic sequence, it is a sequence where every term after the first is obtained by adding a common difference. If we subtract any term from one that follows it, we will get 3. Thus, the first term and the common difference are the things that are common in them. Also, when rewritten, notice the relationship of n to the number that is multiplied to the common difference. If n equals 1, we multiplied 0 to the common difference. If n equals 2, we multiplied 1. If n equals 3, we multiplied 2. And if n equals 4, we multiplied 3. That number is actually n decreased by 1. In general, we have a sub 1 plus n minus 1 times d. Thus, to determine the nth term of an arithmetic sequence, we have a sub n equals a sub 1 plus n minus 1 multiplied to d. Let us go back with the arithmetic sequence formed by matchsticks: 4, 7, 10, 13, 16. What is the 50th term? We have the following given: n equals 50, a sub 1 equals 4, d equals 3. We are looking for the 50th term. The first step is we use the nth term of an arithmetic sequence. That is a sub n equals a sub 1 plus n minus 1 times d. Substitute the given. We have 4 plus 50 minus 1 times 3. 50 minus 1 equals 49. Multiply it by 3. Simplifying it, we have 147. 4 plus 147, we have 151. Therefore, the 50th term is 151. Find the 20th term of the sequence 1, -4, -9, -14. Step 1. Solve for the common difference. Let us use the second term and the first term. D equals a sub 2 minus a sub 1. We have -4 minus 1, and that is equal to -5. Step 2. Substitute using a sub n equals a sub 1 plus n minus 1 times d. We have the given n equals 20, a sub 1 equals 1, d equals -5. Substitute it, we have 1 plus 20 minus 1 times -5. 20 minus 1 equals 19. Multiply it by -5, we have -95. 1 minus 95, we have -94. The 20th term is equal to -94. Find the 12th term of the sequence 81, 64, 47, and 30. Step 1, we need to find for the common difference. This time, let us use the fourth term and the third term. 30 minus 47, that is -17. Now let us proceed with the second step. Step 2. Substitute using a sub n equals a sub 1 plus n minus 1 times d. We are looking for the 12th term. By substitution, we have a sub 12 equals 81 plus the quantity of 12 minus 1 multiplied by -17, which is the common difference. Simplifying it, we have 12 minus 1 equals 11 multiplied by -17, we have -187. 81 minus 187 equals -106. What is the 25th term of x plus 10, x plus 7, x plus 4, x plus 1? First step is to solve for the common difference. Since we are given with binomial, how are we going to solve for its common difference? We have a sub 2 minus a sub 1 equals x plus 7 minus x plus 10. Notice that the subtraction sign has been replaced by adding the second group of terms multiplied by -1. That's why we have x plus 7 minus x minus 10. Combining like terms, we have x minus x plus 7 minus 10. Simplifying it, x minus x equals 0, 7 minus 10 equals -3. So the common difference is -3. Now that we have the common difference, we can solve for the 25th term using the nth term of an arithmetic sequence. We have x plus 10 plus 25 minus 1 multiplied by -3. X plus 10 plus 24 multiplied by -3, we have -72. X plus 10 minus 72. 10 minus 72 is -62. So we have x minus 62. X minus 62, that will be the 25th term of that arithmetic sequence. Determine the nth term. A sub 1 equals 7, d equals 3, n equals 25. We are looking for the 25th term. Since we already have the values that we needed, we just substitute the given. We have a sub 25 equals 7 plus 25 minus 1 times 3. 25 minus 1 equals 24. Multiply it by 3, we have 72. 7 plus 72, we have 76. a sub 25 equals 76. Find a sub 1 if a sub 8 equals 54 and a sub 9 equals 60. Step 1. Since the given are two consecutive terms, then we can find D. Subtracting the two consecutive terms, we have 60 minus 54 equals 6. Step 2. We can now substitute the given to find the first term. We have a sub 9 equals 60, a sub 8 equals 54, and D equals 6. Let us consider the ninth term as the last term, so we will use n equals 9. By substitution, we have a sub 9 equals a sub 1 plus 9 minus 1 times 6. So we have 60 equals a sub 1 plus 8 times 6. 8 multiplied to 6 is 48. Using the addition property of equality, we have negative a sub 1 equals negative 60 plus 48, that is equal to negative 12. Dividing both sides by negative 1, we have positive 12. So the first term that we are looking for is equal to 12. If you try using the 8th term 54 and n as 8, you will get the same. A sub 1 equals 12. How many terms are in the arithmetic sequence if the first term is negative 3, common difference is 2, and the last term is 23? Step 1. Identify the given. A sub 1 equals negative 3, D equals 2, A sub n equals 23. Equals negative 3 plus n minus 1 times 2. Using the distributive property, we will have 23 equals negative 3 plus 2n minus 2. Simplifying it, we have 23 equals 2n minus 5. Using the addition property of equality, we have negative 2n equals negative 23 minus 5. Negative 23 minus 5 equals negative 28. We only need the value of n, so we divide both sides by negative 2 so that we will have 14. Thus, there are 14 terms in the arithmetic sequence. Find the common difference of the arithmetic sequence with a sub 4 equals 10 and a sub 11 equals 45. Step 1, we just substitute the given to the nth term. For a sub 4 equals 10, we have a sub 4 equals a sub 1 plus 4 minus 1 times d. 4 minus 1 equals 3 times d, we have 3d. So we have 10 equals a sub 1 plus 3d. Applying the addition property of equality, we will have a sub 1 equals 10 minus 3d. Since we do not have an exact value for a sub 1, let us consider it as an equation 1. Next is a sub 11 equals a sub 1 plus 11 minus 1 times d. 45 equals a sub 1 plus 10d. Again, using the addition property of equality, we have a sub 1 equals 45 minus 10d. And let us consider it as equation 2. Step 2. Equate equation 1 and equation 2. Equating two equations, we have a sub 1 equals a sub 1, and by substitution, we have 10 minus 3d equals 45 minus 10d. Applying the addition property of equality, we have negative 3d plus 10d equals 45 minus 10. Simplifying it, we have 7d equals 35. To get the value of d, we divide both sides by 7, so we have 5. Thus, the common difference is equal to 5. What must be the value of k so that 5k minus 3, k plus 2, and 3k minus 11 will form an arithmetic sequence? Step 1. We need to solve for the common difference. Again, we have the first 3 terms, a sub 1, a sub 2, and a sub 3. Let us use the first and second term to get the value of the common difference. We have k plus 2 minus 5k minus 3. Then, d equals k plus 2 minus 5k plus 3. Notice that the subtraction sign has been replaced by adding the second group of terms multiplied by negative 1. Then, k minus 5k plus 2 plus 3. That is because we combine like terms and simplifying it. So, we have k minus 5k equals negative 4k and 2 plus 3 equals 5. Thus, the common difference is negative 4k plus 5. Let us consider it as equation 1. This time, let us use the second and third term. We have 3k minus 11 minus k plus 2. It will become 3k minus 11 minus k minus 2 because we applied the same process. And then, we have 3k minus k minus 11 minus 2 because we combine like terms. Now, let us simplify it. 3k minus k equals 2k and 11 minus 2 equals negative 13. Thus, we have 2k minus 13 and that is our equation number 2. Equating equation 1 and equation 2, we have negative 4k plus 5 equals 2k minus 13. Applying the addition property of equality, we have negative 4k minus 2k equals negative 13 minus 5. On the left side, we have negative 4k minus 2k equals negative 6k. On the right side, negative 13 minus 5 equals negative 18. Dividing both sides by negative 6, k equals 3. To check, substitute the value of k in the given terms. We have 5k minus 3, k plus 2, and 3k minus 11. Substitute the value of k to the first, second, and third term. We have 12, 5, and negative 2. To check whether they form an arithmetic sequence, we get their common difference. Negative 2 minus 5 equals negative 7, and 5 minus 12 is negative 7. Thus, it is an arithmetic sequence.